Hey everyone, welcome back. In today's video, we're going to solve a really interesting problem on center of gravity. Here's the challenge. We have a thin circular metal sheet, a smaller circle is cut out from one side, and then that exact piece is placed on the opposite side. Where will the new center of gravity lie? Before I show you the solution, pause the video right here, grab a pen and paper, and try solving it yourself. Then continue watching to see if you got it right. First things first, what do we mean by the center of gravity? Well, the center of gravity of a body is simply the point where the entire weight of the body appears to act. In other words, it's like the average position of all the tiny particles of mass that make up the object. Now here's the problem. We have a thin circular metal sheet of diameter 10 centimeters. From this sheet, a smaller circular section of diameter 5 centimeters is cut out, but not from the center. It's cut from one side of the center, let's say the left side, and then that exact small piece is placed on the opposite side of the disc, which is the right side and in a symmetrical position. The question is, where will the new center of gravity of this final arrangement lie? Okay, let's break this down. Step 1. The big disc has diameter 10 centimeters, so its radius is 5 centimeters. The area of this disc is pi times radius squared, therefore the area will be 25 pi. If the mass per unit area is sigma, then the mass of this large disk is 25 pi sigma. And of course, since it's a perfect disk, its center of gravity lies right at the origin, at the center. Now let's do the same for the smaller disk. It has a diameter of 5 centimeters, so radius is 2.5 centimeters. Then we plug in our data in the same formulas to find area and mass of the smaller disk. Now let's think in terms of mass system. We can think of the final figure consisting of the following. A. The original big disk, having mass 25 pi sigma and center of gravity lies at the origin. B. Removed small disk, having negative mass at that position, and its center of mass was supposedly at negative 2.5 centimeters in the x-axis plane. C. Added small disk, having positive mass and its center of mass at plus 2.5 centimeters in the x-axis plane. So this is our system of masses. Now, to find the new center of gravity, we use the formula for the center of mass of discrete masses, which is the same as the center of gravity for a uniform gravitational field. The formula for the center of mass is found by multiplying each object's mass by its position, adding them all up, and then dividing by the total mass. Since our mass is shifted in x-axis plane only, we will use the formula for the x-coordinates. Let's recall our data and plug them into the formula to get new center of gravity. Now we just have to assign masses and positions to our formula. Therefore, the center of gravity of the final arrangement is 1.25 centimeters from the original center of the large disk, on the side where the small disk was added. And that's it. We found the new center of gravity. If this helped you understand, make sure to like the video, share it with your friends, and subscribe for more problem-solving tips. See you in the next one.